Hi, everybody. Today's lecture will be how to find the signal in time domain if its frequency domain given. Another way, we're going to say how can you apply the inverse of the Fourier transform. So the Fourier transform will be given and it will be required to find the original signal f of t. We'll explain that by example, but before we do that, what is the formula used to find the signal in time domain? Well, it's f of t, the inverse of Fourier transform, is equal 1 over 2 pi, the integration from minus infinity to infinity, and then it's given the f capital, the function of omega, e to the power j omega t, and the integration with respect to omega. So it's different than the formula used to find Fourier transform if ft is given. All right. Let me just write here, just remember, to find the Fourier transform if f of t is given, we make the integration, but the difference is you multiply it by e minus j omega t and you integrate with respect to time. So that's the difference between finding the Fourier transform of a signal given in time domain and how you do the reverse operation, how to find the signal in time domain if the Fourier transform of the signal is given. Let's just apply this by an example. Let's say that in this example, f of omega is equal to a rectangular function omega minus 10 over 2 pi. So this is the function in Fourier, function in the frequency, and the required is to find the corresponding function in time. Well, to do that, we did before some problem has rectangular function, but let me review with you what's rectangular function first. The rectangular function, the basic one, look like that. That's the time domain. And it's equal to 1 start from minus 0.5 up to 0.5, and it will be 0 outside this range. Make it clear for you. And the height is equal 1. And this function is called rectangle, and it's written like, if this is time, will be like that, equal to 1 if t greater than half minus half less than positive half and 0 elsewhere. And the same function, if you express it in omega, frequency domain, all what's supposed to do, you just change the time to omega. So change this one to omega and change this function to omega. So that's the rectangular function. This one is a rectangular function, but just, there is shift, scaling, there are many things in it, and just not only function of omega. So our job first to adapt this formula given to the standard rectangular form. How we'll do that? All right, we'll take whatever inside, it should be less than minus half and bigger than positive half. So what's half inside here? Omega minus 10 over 2 pi. So you write omega minus 10 over 2 pi. So it should be greater than minus half and less than 1/2, because that's in the rectangular function. Now try to find the limit of omega. So you multiply both sides by 2 pi. So what's left? Omega minus 10. If you multiply by 2 pi, so you have minus pi, pi. and then you add 10 to both sides, so you get omega only. You add 10 to both sides, so you have 10 minus pi to 10 plus pi. So we got the limit for the function given in the problem here. We adapt it to the standard rectangular form. Now we're going to start to apply this formula to the integral form of the inverse of the Fourier, which the top one here. I will write it again. F of t is equal to 1 over 2 pi, the integration from minus infinity to infinity, the function of omega, ej omega t d omega. The function in our hand now, it doesn't start from minus half to positive half as we just did now. So if you wish to sketch it, this is the 1 omega minus 10 over 2 pi. That's our original function, and we found out from the limit from 10 minus pi to 10 plus pi. Be 0 outside and 1 inside. So now I'm going to apply the formula here. Obviously, I'm not going to start from minus infinity to plus infinity because it's 0 outside the range, 10 minus pi, 10 plus pi. So I will say here that's 10 minus pi to 10 plus pi. And of omega is equal 1. The magnitude is equal 1. It can have another amplitude, it's okay. Just you put the number here, but it is equal 1. And now we have to find the integration of this formula. So when you do the integration, that's what you got. 1 over 2 pi is the constant. So right here, f of t, 1 over 2 pi. And the integration of ej omega t will be ej omega t over j omega, and the limit 10 from 10 minus pi to 10 plus pi. We'll start to substitute. First, I'll take the constant outside, j 2 pi omega, and what's left here, e j, and you got to remember we are integrating with respect to omega, so that should be t, because we are integrating with respect to omega, so t will be constant with respect to omega. Now I will start to substitute by omega, the 10 plus pi, so you have omega 10 plus pi times t minus e j 10 minus pi t. All right. Now what I'm supposed to do, let's fix that to jt. I mean, we have jt here, so that should be t. Now, just let's simplify it. How you simplify that? Very simple. 1 over j 2 pi t, and this one ej 10 ej by t, and ej by t is constant with respect to omega. So let me just, make it easy for you. J, this one, I'm doing this one, j 10 t and plus j pi t, and the other one will be minus a j 10 t minus j pi t. We are going to take which one we're going to take constant, j 10 t from both sides as a common factor. So you have a j 10 t divided by j 2 pi t. So what's left? ej pi t minus ej pi t. And again, we know the formula for the sine. When we say sine theta, we say it's equal to ej theta minus e minus j theta divided by 2j. From this expression, we can say that e to the power j theta minus e power minus j theta, it will be equal to j times sine theta. We're going to this expression in this one. So this one is constant first. Let's write f of t is equal a j10t divided by j2 pi t, and now this expression, this exponential, be 2j times the sine of this pi t, be 2j times sine pi t. Well, 2j cancel with 2j, so you have ej10t divided by pi t sine pi t. Well, that's interesting. ej10t, and you make sine pi t divided by pi t here. You remember from last lecture, this one we call it sec pi t. So ej10t times sec pi t. So that will be the expression for the time domain. And if you sketch it, that will look like that. F of t with time, the sec be like that, and then because it's multiplied by e power j, then be like and decreasing when it's go to infinity. So that will be the inverse of Fourier transform. Okay, I hope that was easy. All right, thank you.